All right, so end behavior is describing the far left and the far right portions of a graph. So it's saying which way are our arrows going. So in a parabola, for example, our end behavior is going up and to the left and up and to the right. Okay? So we're going to use the leading coefficient and the degree of the polynomial to determine the end behavior. So we can graph every single function and figure out what the end behavior is, or we can do this leading coefficient test to figure it out. Okay? So here, this whole thing is the leading coefficient test, okay? So let's start with x squared. Okay, so if I have a degree that is even, so we're going to talk about degrees being even or odd. Okay, so I have an even number here, 2 is even. And if I have a leading coefficient that is positive, so if I have a leading coefficient that's positive, it's face up, right? If it's negative, it flips over. Okay, and so the end behavior, here's how we'll describe it. As y is going to negative infinity, so if it's going to the left, we'll say left or negative infinity. Oh, I'm sorry, that's not right. We're trying to pay attention to x here. So as x is going to infinity, so as we're going this way, y is also going to infinity. This is going to the left, or to the right. Goodness. And this is saying as x goes to negative infinity, because negative infinity is all the way over this way. So that's going to the left. Then we're also approaching infinity. So that's all the end behavior means. Okay, and so I'm going to show you really fast. If I were to type in, sometimes we get caught up on the fact that this is squared. So I'm going to show you that every even function, or at least a lot of even functions, are this way. Okay, so here if I do x squared, our starting one, this is x to the 4th, x to the 6th, x to the 8th. Okay, you can see that every single one of these, oh geez, come on. Every single one of these graphs, their shape changes a little bit, but they are going from the left, they're going to infinity, and to the right, they're going to infinity. So, you see that? Okay, that is true for every single graph that is positive and even. All right. Let's look at this one here. So negative x squared. So this is similar, except it's been flipped over because of that negative sign right there. So our degree is still even. And our leading coefficient is negative this time. That's what's different, is it's negative. Okay, and then here's our end behavior. So as x is going to infinity is all the way over to the right. Y is going to negative infinity. So as we're going positive this way, our y's are getting more negative as well, or getting more negative. Okay, and the reason why we say negative infinity is because, remember, this has arrows. It doesn't have the arrows because it gets cut off, but this goes on forever. All right, this goes on forever and ever and ever. So it's never going to reach whatever point that is, so that's why we say negative infinity. Okay, and then y, as we're going to, x is going to negative infinity, where's y going? Careful. Negative infinity still. Okay. All right, then x to the third. So this is going to be a degree that is what is 3? 2 is even, 3 is odd. In this one, I have a leading coefficient that is positive. Okay, and then here's the end behavior. So as x is going to infinity, we're going this way. Where is our y going? So as we're going this way, where's it going, up or down? What is it? Infinity. So as we're going to positive infinity, this is also going to positive infinity. Okay, so when I say positive infinity, I mean it's going up. If I say negative infinity, it's going down. We're going to positive infinity. And then as x is going to negative infinity, where's y going? What's that? It's also going to negative infinity. So as we're going negative infinity, this is also going to negative infinity. Okay, so I'm going to show you a bunch of odd functions now. Where'd it go? Here it is. So let's do x to the third, x to the fifth, x to the seventh, x to the ninth. You know what, let's make it fun and make it a really big number, okay? So I'm gonna zoom in a little bit. The x to the ninth looks really weird. So as you can see, all of these, even the x to the ninth, it's just really, gets really sharp there. But they all are going from, on the left, they're going to negative infinity, and to the right, they're going to positive infinity. So they're going up and up and up forever and ever. Okay. And our graphs are, do we have on our, on here, it looks like they kind of stop someplace. Remember, they're going on forever. And also on our graphs that we just put on Desmos, it's much sharper, and you can see that it's going straight up. It's not going at a diagonal. So maybe sometimes that is easier for people to visualize. All right, so then here we have a odd degree. The leading coefficient is negative. And then our end behavior, as x approaches infinity, y is going to negative infinity. And as x goes to negative infinity, y goes to positive infinity. So it's just the opposite. And it's the opposite for both of those. Okay, so what we're going to do is we're not going to use graphs. We can use our graphs to check our answers after we're finished. But what we're going to do is we're going to take the function, just a function, and we're going to determine what the end behavior looks like when we're finished. Now this is something where if we know the end behavior, then we can kind of get an idea of what the graph is going to look like based on, remember when we found the zeros, this end behavior, and then also this thing called multiplicity, which we haven't covered. So all of those things we can use to create a graph without ever graphing points. Okay, so it's just like a general picture thing. All right, so this is how we're going to do this. Okay, so I would go ahead and write out each of these steps. I'm going to put this away first. Pause for a second so you can get this down. Where's my mouse? There it is. Okay, so just focus on number 1 for now. So we've got f of x equals 2x squared plus 3x minus 5. And then it says, first determine whether the degree of the polynomial is even or odd. Next, determine the leading coefficient is positive or negative. Then determine the end behavior. So these are your steps. You want to make sure you write those out. That way you have them for later. When you finish, set your pencil down, look up so I know that everybody's ready. Thank you so much.
You go. I'll see you through at 10.
Mm-hmm. Okay, I think people are about finished with that. All right, so it says first determine whether the degree of the polynomial is odd or even. So we're going to look here at our degree, and someone raise your hand and tell me, is that odd or even? You didn't raise your hand. I'll accept your answer though. Odd, or I'm sorry, even. Make sure to raise your hand. Okay, so then it says next determine whether the leading coefficient is positive or negative. What do you guys think? Chase? Positive. And you guys can use the cheat sheet for now to determine the end behavior. However, eventually you're going to get to a point where I want you to think, okay, if I have an even function, I know it's going to be a U shape. Okay? So it's going to be a U shape like this if it's even and positive. So I can even draw a little thing to help me out. And so my end behavior is going to be as x approaches, let's do negative infinity first. So this is the left. As x approaches negative infinity, where is y going?
Positive.
Also positive infinity. It's going up this way. So negative infinity is this way, and our y is going up. So that's positive infinity. All right, and then on the right side, let me zoom in. Sorry, I tend to write really small. As x is approaching positive infinity, then y is approaching Chase? What is it? Look at the graph again. So if we're going towards positive infinity for x, where's y going? Positive infinity, it's going up. So I'm just gonna write this over here. So if it's going up, it's positive infinity. If it's going down, it's negative infinity. Okay? A little bit hard to see. Okay, this next one here, we're gonna do the same thing. We're just not gonna write out all those words. All right, we're not gonna go through that whole thing yet. Okay, so first we need to determine the degree of the polynomial. Now, is the degree odd or even? Somebody can tell me. Jill? Odd. And is the function positive or negative? Connor? Careful. Negative. We got a negative right there. Okay, so those are the two things that determine our end behavior. Now, when we're talking about an x to the third function, it usually looks like this little, I don't know what you would call that. Almost like a lightning bolt or something. But it's negative, so it's going to go like this, the opposite way. All right, so as x approaches negative infinity, y approaches what? And as x approaches positive infinity, y approaches what? Go ahead, take a second, talk to people sitting around you, determine what that end behavior is. If you need to use your cheat sheet, you can. Or you can use the picture right here. Go ahead and talk, guys. Okay, so as we're going to the left, so as x is approaching negative infinity, so we're moving to the left. Someone I haven't heard from, where's y going? Preston?
Negative infinity.
So as we're going to the left,
Positive.
positive infinity. Remember, you can use this cheat sheet we had. So we have odd, negative. I just flipped our x and y. All right. Then as x is going to positive infinity, so as we are going to the right, where is y going? Connor? Negative infinity. Very good. Okay. So there are 3 problems left. 1, 2, 3. I want you to go ahead. I'm going to give you, I feel like a minute per each is plenty. I'm going to give you 3 minutes. I'm setting a timer. You can talk to people sitting around you. You can use your cheat sheet. But I do want you to answer those 3 questions. Guys, go ahead and try. The worst thing that'll happen is you have to erase and rewrite it. It's not a big deal. Okay? Give it a try, please. Okay, take the headphones off. I'm not nasty again. I don't care. You're not supposed to have your headphones in during class. Okay, let's go over these problems. So as we've got f of x equals 4x to the fourth minus 2x squared plus 6x minus 3. All right, you should have said it was even and positive. So someone raise your hand. As x is approaching negative infinity, what is y approaching? Sam? Good. Positive infinity. All right. And as x is approaching infinity or going to the right, where's y going? Connor? Good. Infinity. Okay. Make sure you got that down. Going to the next one. We've got f of x equals 4x to the fifth minus 3x squared plus 2x. You should have said that it is odd and positive. So, as x is approaching negative infinity, where's y going? We're going to the left. Where's y going? What do you think, Wyatt? It's odd. Go look at your cheat sheet. It's odd and positive. So go to your odd and positive one. Did you write it down? Emma? It's going to go negative. Okay, there's no reason why every single one of you shouldn't be able to answer these questions. You have the cheat sheet, okay? I'm not expecting you to know it overnight. All right, so then as y is approaching positive infinity or going to the right, where's y going? I'm going to have her from. What do you think, Jake? As x is approaching infinity, you're going that way. Where's y going? Yeah, positive infinity. All right, on this last one, we've got even and positive again. So as x is approaching negative infinity, where is y going? Xavier? Very good, positive infinity. And then as x is approaching infinity, where is y going? What's your name, Kaylee? It's going to be positive infinity again, because this is the U-shaped one, like this. Like that. Okay? Let's talk about some patterns. Now that we've answered some questions, okay? Just some patterns that you should notice. Okay, so with our even things, if we have a positive out front, both of these are positive. Did you notice that? If we're even and positive, both of these are positive. If we are even and negative, then both of these are negative. Okay? If we're both even and negative, then both of these are negative. Okay? Because we have the U shape, it's going the same, the ends are the same. All right, with odd, if it's positive, these two things match up. So if it's going to positive infinity, it's positive. Negative infinity, negative. All right, so those match up for odd. They're opposite, the ends are going to be opposite for odd. All right, and then for odd and negative, it's flipped. So positive goes to negative, and negative goes to positive. If you did not already copy down the chart, which I get a feeling that some of you did not, take the time to do that. When you are finished, you may start tonight's video or work on any assignments that you don't have turned in. Okay, it's 8:08. We've got about 7 minutes left. Do whatever you need to do to get finished up. But the homework tonight is for